Hi everyone, this is Sandeep Giri and welcome to this session. It's basically a launch event for the course and we are very glad to have all of you in this session. And we have a wonderful audience as of now, and as well as we have great instructors and faculty from IIT Roorkee and the industry and academia in this particular session. So you will get to meet everybody in this session. And we would like to first of all welcome everybody to this launch event of the E&ICT course. And and this is also going to be an introduction to data science, machine learning, and a brief about career in the machine learning and data science domain. All right. So before any further delay, I'd like to invite. Okay, I'll just give you a brief idea about this webinar, those who are new to it. It's going to be 2-hour session with a 10 minutes break at 9 p.m. IST. Except for the speaker, everybody is on the mute. Please use the YouTube chat to ask any question. This is a launch event and it's a public event for everybody. The future sessions are going to be a place where only the people who have enrolled will be allowed in the session. So, but this is open for all. That's why it is on YouTube. Remaining of the sessions will be on Zoom. The recording of this session as well as the slides will be shared with everybody. And you can know about us at cloudxlab.com as well as enict.iitr.ac.in. All right. So the format is going to be this. This is a brief agenda. So, all right. I would like to invite Professor Manhas, who is a senior professor at IIT Roorkee in the electronics side, and he is heading the E&ICT E&ICT Academy at IIT Roorkee to a very high scale, and is probably one of the best performing EICTs in country. I would over to Professor Manhas, who has a wonderful experience and would like to give you an overview about IIT Roorkee and E&ICT.
Yeah, hello. So, first of all, let me say greetings and welcome to all the participants and all my team here, and also uh, my collaborators or the people from CloudxLab. Thank you, Sandeep, for the introduction. And I'm a faculty at Electronics and Communication Engineering Department of IIT Roorkee. Now, in addition to that, I also am a implementing coordinator, or what we call here as principal investigator of this program called Electronics and ICT Academy. Now, to many of you who are probably may not be able to see why we call it as a E&ICT Academy. Now, the idea behind this is like it is also there in other institutes to sort of you know form a specialized unit or a specialized center which is sort of outreaching to outside world, particularly in India and abroad, in dispensing sort of programs and the education in emerging areas where there is a lot of need and demand. So next slide, please. This project I would like to tell is actually also initially was funded through a program from Ministry of Information and Communication Technologies. Now IIT Roorkee, I would say probably need not that much of an introduction. This is an oldest engineering college in India. It was established by Britishers. Those days it was called Thomson College of Engineering. Now it has been in existence for nearly 170 plus years. So it's a long history. And it's a beautiful campus with all kind of legacy that if you ever visit here, you'll see and like. You can see things from British era. You can see how India evolved. and some of the things are really very well blended in terms of history of India. Now we offer 11 bachelor degree programs and nearly 55 different post degree programs. We have about 20 plus departments which are equipped with the latest facilities of all the engineering areas, civil, mechanical, electronics, computer, chemical engineering, etc., etc. And we have students from more than 50 different countries. Okay, and we largely offer full-time programs, although we also do a lot of short-time training courses also. Next, please. Now, so you can, if you, I just wanted to highlight or tell you about like how IIT Roorkee is perceived in academic and otherwise outside world in terms of its ranking. So we actually are first among IITs in citations per faculty. Now, the IIT Roorkee has really built on its sort of strength in terms of research, and a lot of really cutting edge different type of research is being done by the faculties from different departments, and the rigor in academic is really very high, and that is reflected in citation that we get uh, from the papers and other different articles that are published by the faculties in IIT Roorkee, and we are actually at the top. We also are at number 6 nationally among various other institutes like IITs and IIScs. Also, we actually rank number 1 as citation per faculty, which I already told you, uh, nationally, and internationally we are among at number 20. So you can see that really speaking, we are something like top 100 type of university in the world, and this all is because of very high quality of both research, education, as well as the innovation that we IIT Roorkee faculty, students, alumni have done over the years. And this is all something which actually makes us also very happy as well as proud. And I'm very sure that over the course of this program, also, you will also appreciate amount of effort and quality that we like to that you will see during this program also. Next, please. Just very brief about this program, which we call E&ICT Academy, because the course here is floated and organized by E&ICT Academy in partnership with our CloudxLab. And really, actually, we started as a program funded by Government of India, MIT. This basically is a ministry program, and we started way back in 2016, and our goal is to empower various stakeholders at as of today in various domains, including engineers, scientists, professionals, and even the graduates who are coming out of universities to some of the cutting edge technologies in ICT sector, particularly in the era of 5G and AI. So we really are focusing a lot on delivering high quality programs in machine learning, AI, and data science, as well as IoT and other hardware platforms like embedded and robotics. So our goal and our philosophy is to create the programs where is a very balanced mix of both academic rigor but also practical applications, and that is one reason why we involve our program partners and through their sort of participation we bring in some of the really top notch experts who are working in industry with the objective that they will bring in something which is of importance to industry, and that learning is then transformed to you so that you get exposed to practical problems of the sort of top notch people from the world. Next, please. So these are some of the things that really we strive to implement. The programs are really very well curated and very well sort of planned by professors at IIT. So this program is also has been looked into very detail along with my two colleagues here, Professor Gaurav and Professor Raksha. and also we worked with our implementing partner also. And we work with a philosophy that in addition to building your fundamentals, hands-on learning, in bringing in the experts from industry, and also try to create a sort of overall ecosystem or create an atmosphere which we are able to kind of bring in industry-like feeling of learning with the professor, with an open philosophy of letting our learners access to video lectures and better other materials too. Now, over the last 4 years, we have already impacted and benefited more than 10,000 different participants in various different side type of programs. And our overall feedback in terms of the quality of program has been really very good. It's more than 9. Okay, we're constantly hitting 9+ in the feedback that we get from our participants for all the programs that we do, and we always have a participation both India and abroad. Next. Yeah, so I would like to hurry through because I have been given a very sort of limited time slot considering the overall program that we want to do. Now, this is something, the data that has come from a industry body called NISCOM in India, and it has sort of projected what are the sort of key technologies which are going to be implemented worldwide or being adopted by various organizations, companies, and governments and other places. And you can already see that the top is basically driven by data, machine learning, and that kind of analytics around it. In addition to that, there are hardware-based programs or the technologies like Internet of Things or Internet of Everything, and also augmented reality and virtual reality. So these are the areas which are actually are in very high demand in terms of getting sort of prospects or opportunities from industry. And if you train yourself or if you equip yourself in any one of these technologies, future is, I would say, very bright. Next, please. Now, this is another data that we have put together from various sort of bodies who look at who look at what is the job scenario and where are the gaps, etc. So, in general, it is felt that even today there is almost like 30 to 40% of the tech jobs are still kind of unfulfilled. Of course, they are looking for right sort of talent, and this is something which is right to be tapped in by developing right sort of core skills in these areas, and make something a brighter future for yourself and also others, your colleagues, etc., and organizations, and so on. Next, please. Yeah, so I think that's my last slide. So I would like to stop. If anybody has any questions, so I think we can
Yeah.
take on at the end. So it's over to you, Sandeep.
Thank you, Professor Manas. That was a very informative session or informative introduction of E&ICT. And so I would like to do a bit of, about CloudxLab now. This part, I would hand it over to Abhinav. Abhinav would like to walk you through a brief about what exactly is CloudxLab, and then we will also talk about the course after this, and then we will introduce everybody with the instructors, and that's how we're going to do. All right, over to you, Abhinav. Please go ahead.
Hi all, I hope I am audible.
Yes.
Great. So hi all. So now I will introduce about the company and the kind of work which we are doing as a small team. So we are a very small team of engineers with a focus on upskilling engineers in the field of AI, machine learning, Hadoop, and Spark. Our focus is on imparting the knowledge which is hands-on. So we believe that we learn faster and better when we learn by doing lots and lots of hands-ons. So I will just introduce the various functionalities which we have in our LMS as well as in our assessment engine, so that we will know that what all things we have or what all things we will have in the course. So this is our interface where you can go and see all your courses. And if we will go inside any course, we will see here topics, and I will just show you the assessment engine. So this is something which is unique to us. So on the left-hand side, we will see the content and the instructions, and on the right-hand side, we will see our assessment engine, the lab, where we have to do hands-on. And in the lab, we have already configured all the tools and softwares which you will require to do hands-on or for practicing. Let me show you one very simple example of string concatenation and how our assessment engine will check it out. So here I will follow the instructions that I will have to assign certain values to some variables, right? And after that, I will do the string concatenation of first and second. And let me see if my answer is okay. I'll say submit answer. System will go and it will check that if we have done everything according to the instructions. And see here.
Yes.
Just me.
Actually, the L is small.
Yes.
So, okay. Yes. So wonderful.
Okay. So now, if I will submit the answer, the system will go and see it. I mean, if I have followed all the steps properly. Yeah. So this is how our entire LMS and our entire assessment engine is built, where at every step we will see that if you are following all the instructions and steps. And what we have seen that if we have this kind of interface with the feedback, the overall completion is higher. I mean, in our all the courses, we have a very, very high completion rate. Apart from these elements, we also have our own forum. And in the forum, just a second, let me go from here only. So in this forum, I mean, if you have anything on engineering in the field of software, algorithms, machine learning, AI, Hadoop, and Spark, you can simply come to the forum and ask the question, and our entire community will help you out, will assist you.
Other than the discussion we have below every topic. So there's a lot of interaction on each topic, as well as the where you were seeing the just now.
Yes, I can show it again.
Yeah, I think this is good. All right. So,
okay, and apart from this, we have our own hiring portal where we have partnered with a lot of many companies where after the course, if you want to apply for the jobs, you can apply from the interface. One thing which is very, very unique to us and which we are doing in the field of education is that we want to make education as a social experience where we will be able to share our achievements, our success, our overall completion rate with the entire community. And it's a very, very engaging feature which is being appreciated by a lot of our customers. So that was the brief overview of the company, the kind of thing which we are doing as a startup. If I have if I have missed anything, Sandeep, if you want to add anything.
No, I think that was pretty much. Thank you so much for a very good hands-on demo as well as presentation. I think the people who are going to join this course, they are going to really appreciate this part, because there are hundreds of platforms out there, but we can proudly say that the tools that you have just demonstrated, we basically are way ahead of most of our competitors when it comes to imparting knowledge. There's a social angle, there's a job connection, there's a gamification, and there's a entire discussion model. So we concurrently have we have had total so far more than 200,000 learners, and we have had concurrent users more than 50,000. And that's something that we have seen in past. Okay, so thanks to all the tools. So we are essentially a strong technology company as compared to, and what we are doing is we are essentially helping education institutions like E&ICT and IIT Roorkee in order to impart the best knowledge possible. All right, so that was a brief about it. So I want to give you an overview about this course. This course, again, everything that we have taken up so far is generally on the Google's philosophy that it has to be 10 times better than any competitor. So same is the case that we are talking about this current course. This current course is one of the deep dive courses whereby you have one of the most wonderful faculty and mentors. You have professors from IIT Roorkee, as well as you have people from the industry. And I'll basically give a brief intro very soon. I'll let everybody introduce themselves. And this is what makes this course really, really, really interesting. None of the courses on internet today have course better than this. Not only the other than wonderful faculty, what we have done is we have created a blended learning experience. The environment which Abhinav just showed you, we have around 29 projects in that environment, which will essentially just give me a moment. Okay, so so which will give very good experience, hands-on learning experience. Is my voice clear or is there a break? Any of the persons can help me understand.
It's fine. Yeah, it's all fine.
Okay, wonderful, wonderful. So we have basically 11 months of blended learning. This course is going to be most foundational. Today, if you go for a job at any of the top companies, they ask you machine learning questions, they ask you coding questions, and they ask you the backend design questions. Okay, the way we have designed the course is that you will be able to clear all those rounds, and that's how we have designed the course from bottom up. And we have seen in past all the learners that we have had as part of the courses with IIT and E&ICT, most of the learners have been really, really successful. So you'll get a certificate of completion by E&ICT, but you will have to work on that. You will have to finish the project. You will have to do the final capstone project, as well as you have to finish all the exercises. And the curriculum in this course you will find as one of the the best one, because starts with foundations, goes into deep, and the course curriculum is actually equivalent of any 2 years of masters. And I mean, most of the things that you will see in this course is something cutting edge, something that has come up in last 6 months. So most of the papers that we will be reviewing and so on, you will find that most of the knowledge that you are gaining is something cutting edge. It's not something very old. This is going to be including reinforcement learning, GAN, RNNs, CNNs, and then of course the classical part like random forest, SVM, classification, regression. And the other part is the scalable machine learning. I think that part Venkat will make it more clearer as when he talks about it. So I will. So this is the course that we are talking about. This is 10 times better than anybody in the market, and I can vouch for this. The overall experience, I can tell you that when you walk out of this course, you will be able to have that confidence to appear for any interview. And this is how we mostly put our everything on the edge to make sure that you will be successful as part of this course. All right, there are a few seats left. The batch starts on 28th March. It is going to be 8 p.m. to 11 p.m. because on Saturday, Sunday. Most of the people who have already enrolled in this course are basically professionals, and they are from across the globe. And you will be able to connect and build great friendship during the course. And what we have done is, instead of we have capped the fees to be EMI, like monthly, so that it doesn't hurt you much. And instead of going with any loan or something, we have ourselves designed the entire EMI system. So that was about the course. And all right, I would like to have a brief intro of everybody in the faculty of this course. Let's start. We have had a brief intro about Professor Manhas, and Professor Gaurav, you could go ahead and then.
Yeah. Am I audible?
Yes, very much.
Yes. Hi, everyone. This is Dr. Gaurav Dixit. So I am faculty in the Management Studies Department of IIT Roorkee. And my area of expertise has been machine learning, data science, IT strategy, and e-commerce. And based on the previous experiences, I can say that this particular program is going to offer more end-to-end complete feel and experience of what data science is about, what machine learning is about, and also the big data technologies along with that. So looking forward to see you in the sessions. So looking forward to meet you and learn and interact with all of you. Best wishes.
Wonderful. Thank you, Gaurav. Thank you so much. Praveen, would you like to go ahead?
Hey folks, Praveen here. I've been listening through. So hi everyone. Hi Gaurav. Hi Venkat. Everybody. It's nice to see all of you again. Hi everyone. So Praveen here. I will be a part of the faculty. So briefly about me, I am currently the CTO of Yathas Telematics. It's an IoT plus an edge analytics company. And I will be contributing to sections on computer vision and deep learning in this course. So I'll just keep it short. There's a long session today. And later, in case there are any questions specifically for me, let me know. I'll answer them. Thank you, guys.
Wonderful. Abhinav, would you like to introduce? Sorry.
Hi all. Hi again. So for me, I am engineer at heart, and I uh, I love to solve challenges and problems. My entire experience has been into startups where I have built large scale systems for some of the successful startups of uh, India. And in the course, I will be taking the sections in Hadoop and Spark.
Okay. So by the way, he worked with the Byju's in the early days. And all right. So we have Professor Manas. Would you like to introduce again or?
Yeah, so thank you. So I will just briefly tell about myself. I'm a faculty at Electronics and Communication Engineering, and I've been here with IIT Roorkee about 10 years now. I Prior to this, I was I have done my PhD from UK, and I also did my master from IIT Madras. And I worked in actually a wafer fab R&D in Micron, both in US and Singapore. Now, just wanted to tell you that my experience with let's say data is something which I can directly correlate back to in a wafer R&D, where you have maybe 100 tools, and each tool is every second producing so much of data, and that data need to be analyzed. So those days engineers will sit on it, and they all pour over the data over hours and hours and try to make something sense of the data, generate something, make a decision. Whereas I believe today, although I'm not in a bit for R&D, but the same thing, a lot of things are done based on machine learning and AI algorithms. So the world is data driven, and practical data is not always explained by theory, and you need this kind of smart algorithms to make smart and intelligent and maybe really something decision which are later on you don't regret. So you learn something here. I will really be very useful wherever you go. So thank you very much, and I will stop here.
Thank you, Professor Manas. Venkat, would you like to introduce yourself?
Thank you, Sandeep. Hello, folks. Can you hear me?
Yeah.
All right. My name is Venkat Karun, and I work as a ranking engineer in Google. I have a 13-year career in Google, where I spent 8 years in Mountain View, working on the Google homepage team, where I have 3 patents on that work. I moved to Brazil 7 years ago and work out of the only engineering office in South America for Google. I collaborate a lot with Google Research, and essentially my interests are high performance computing and machine learning at scale. Well, in terms of machine learning, I wrote my first Bayesian classifier for sending customer support responses in 2008. And as far as the course goes, I will be coordinating with Sandeep on the deployment aspects, like, the living, breathing AI, making it manifest in the real world. And just sort of like a great point thing, I started my career as a trading systems engineer at DE Shaw Group, along with Sandeep, who was sort of a mentor and taught me the art of SQL injection. So thank you, Sandeep.
All right. Wonderful, wonderful. So yeah, those who don't know D-Shaw was the big data company before the term big data came into the world. And yes, we had around 8,000 nodes. And Jeff Bezos was at D-Shaw. Okay. So those are that's where we met. So wonderful. So great to hear your intro, everyone. About myself, I'm a 2002 pass out from IIT Roorkee, and I'm very proud of the fact that I graduated there. This is one of the best colleges, and after that I joined DE Shaw, where basically we worked on a large scale computing, and we managed a lot of things on Postgres. and everything seemed to be at that point of time, even simple anti-money laundering was of a humongous AI problem. And after Amazon, after the Shaw, I founded a company, and using that product, most of the power plants in India are built. After that, I worked with InMobi, where I processed around 200 terabyte data, and to give the recommendation to the customers. After that, I joined Amazon, where I built the mobile app. If you click on buy now in Amazon app, and if the buy now button vibrates a little bit, that means you're using my version. And I built basically the pipeline to improve the images of the improve the images that are displayed on every product page. Afterwards, I started CloudxLab in 2016. And before that, I just started teaching people scalable computing using Spark and Hadoop. And CloudxLab became very, very successful when it came to the lab. Most of the people in the education technologies, they use our lab to impart knowledge. And we are very proud of the fact that most of the premier institutions across the globe are our users. And and we basically have enabled them to give this experiential learning, and we continue to do that, and we will be doing that more and more. We are also working a lot on understanding the learning behavior of individual. So we are continuously applying machine learning to understand where exactly is the fault in the content, the self-paced content, and that needs to be improved. So we are building the internal way of identifying the bottleneck in the content, and we have enormous amount of data by now that we are confident that we'll be able to identify or build a model which will be able to tell that this content is good, this is bad, from the perspective of the learning. And that is something that we are super proud of. And it is becoming a social platform where lots and lots of users are posting things and talking with each other. Just like LinkedIn is for professional work, ours is LinkedIn for education. And that's how we are going to be. Perfect. So that was a brief intro about myself, and thank you, everyone. There are a couple of questions that people have asked. One of the question is how hard it will be for a person to pick up the concepts, how many hours we need to put in every week. So first of all, if you are not able to pick up a concept, it's also our responsibility. Okay, so that's why what we have done is we have brought in the fundamental concepts from the scratch, including how to use Linux, how to use Git, how to use SQL. Like there's a full course on SQL as a complementary in this course. So the thing is that we are going to make sure that you would be able to pick up the concepts. Okay, so if it is hard, let us know at every point of time. I personally would like to make sure that you are up to the speed. Okay, and we will do complimentary sessions, and that's what we have done in past. That no matter what happens, in case you're left behind, don't get left behind. Just let me know so that I can organize complimentary sessions during the week so that you can catch up. And that's how we have done in past. We have never let any of our learners left behind, and we have made sure that we went
And
overboard.
just yeah, Sandeep. So in addition to what you mentioned, and if any of the participants, or if there is a sort of few pool of people and they want to have a special session with one of the faculties here, we'll be very happy, and our faculties will
Oh,
be
wonderful.
available, and we'll do our sort of best. And with your coordination and sort of channeling of the right sort of people to right direction, I think we will be able to as you rightly mentioned, it is not that you don't feel that if you're not able to catch up and you might miss out. It is not.
Right.
We will ensure, as long as you are patiently and also committing time. There's no reason that you won't be able to finish this course and sort of fulfill your expectations.
Right. Right. Thank you so much. That is such a
If Professor Gaurav want to say anything, please
yeah.
feel free to do so.
You're on mute, so please go ahead, Gaurav. Yeah.
Yeah, I think as Professor Manas said and Sandeep was saying, so the program is, designed in such a way that we cover all bases. We cover concepts, we do hands-on exercises, assessment on the platform, and Q&A sessions. You got forum also. So all bases covered. This is one platform. This is one program where all the components of blended learning, they are there. So everything is designed, everything is for you. So nobody is going to be left behind. So we are thinking about you. We're thinking about the learners all the time. So there is no need to worry in terms of learning and progressing well for your career.
Perfect. Perfect. Thank you so much. I think this is the reassurance that that the learners needed from our side. So no matter what it takes, we are going to make sure that everybody is on the speed and successful in their career. Next question is how many hours we need to put in every week? It's going to be 2 to 3 hours. Okay. Some chapters are going to require way more work. Some chapters may require less work, but minimum 2 to 3 hours per week, other than the classes, you have to put that much work because there's lots of exercises. There are lots of projects that you have to finish during the course. And trust me, from the perspective of us, we can do only say 30% of the task. 70% has to be done by you. And trust me on this. Unlike there's a joke that this person takes up a gym membership, and he says that I took the gym membership and it has been 3 months. I have not lost the weight. I'll just go to gym and check what's going on there. Okay. So he hasn't. So at the end of the day, it's exactly like that. So you will have to. We can provide equipment, we can provide direction, training, but we are also going to make sure that you finish the exercises. Only then all the efforts are going to be in alignment. I understand that you will be having commitments from your organization wherever you're working, but I'm sure that if you cut down on your Netflix time, probably you'll be able to spend 2 to 3 hours in a week on the learning. And I'm sure that you, in my past experience, you have, most of the people have done wonderful. And I'm very positive about all the people who are enrolling in this course, given their profile. It's going to be just, you're going to definitely do it really well. There are a couple of more questions in this. It's a wonderful set of questions. So let me spend good time. Question is, I have experience in one of the IITs where the course pace is fast. So that's one of the reasons. So question is that there are other courses which are at fast pace, something like 2 months, 3 months. Yes, we too had that experience. We had run another course for 6 months, and we still realized that we needed more time, and that's the reason why we wanted to do it this time for a longer duration. And that's the reason. The truth is that substance in machine learning is very big. There is a lot of things that have come in recent 10 years, and there is it's a MS kind of a curriculum. So yes, that's the reason why we have taken it to 8 months. Does the course, next question is, does the course curriculum include MySQL for data sciences? Yes, it's not MySQL, it is SQL. MySQL is the database and SQL is the structured query language. SQL is not only used in databases, extended databases. Of course, it is used with MySQL, Oracle, Postgres, almost every database uses the same SQL with a little variance. On top of it, you'll be surprised to know that if you are going for, let's say, a profile in Power BI, you're going for a profile in data engineering, you're doing the processing using the standard tool for cleaning, everywhere you'll find the knowledge of SQL is going to be very, very, very useful. That's why we have included SQL course in this as a complementary. It's a hard course designed by somebody who has been a database administrator in top firms, and he has done. It's just somebody who I really immensely respect. So I'm sure that that SQL course is going to be very useful. Now, on top of it, whether you're going for data science interviews, data engineering interviews, data analyst interviews, almost everybody asks for SQL. Therefore, it is very, very critical. Like there are around 10 people who have recently inquired us about certain candidates that can be hired, and 10 candidates from you just if they know good SQL. So trust me, that would help you. Everything has been pick and chosen based on what industry demands. Wonderful. And a question is a very interesting question. How these courses help in research area? How these help in innovation? I think I'll let Venkat and Gaurav, do you want to pick this question? Question is how these courses help in research area and how these help in innovation.
All right. So I would like to talk about how this helps in research and innovation with an example from something known as reinforcement learning, right? Reinforcement learning is essentially a reward-based approach where think of you are in a maze, you get lost, but finally you pick up the reward at some stage. It's used for self-driving. It's used for various approaches, but I've taken a specific branch of reinforcement learning and worked with a Stanford researcher to publish a paper on something known as imitation learning to learn how to buy movie tickets online automatically. Now think of how many movie websites you have in the world, right? How much different their HTML structure is. You cannot hard code a few rules to find out, oh, here's the buy button. Here's the place where we select Superman 3. So this is an extremely hard problem where you have to take the document object model, think of it in a higher dimensional space, use the latest research to do this. Anything that the Google Assistant does today, right from restaurant reservations to renting cars to essentially buying movie tickets, which was my project, is leveraging the latest and greatest state of the art. And to do this, one needs to have a solid foundational base. One needs, and that this course will definitely provide.
Gaurav, you have something to add?
So I think Venkat gave a very good perspective where product R&D and innovation point of view. Now, as far as scientific research is concerned, this particular program, this particular course will make you ready for that. So you'll have all the tools and skills so that you can follow the typical machine learning AI workflows. And whatever new ideas that you have for doing your scientific research, you will be able to implement that. You'll be able to experiment, different things, different ideas, whether in terms of algorithmic enhancements, whether in terms of feature engineering, whether in terms of different combination, hyperparameter combination, or optimization algorithms. So you'll be ready. You will have all these skills after this program. You'll have all the skills that you'll be able to implement your ideas and actually do scientific research.
Wonderful. Thank you so much. Those were really, really good answers. Anybody wants to add to this? Okay, wonderful. So one of the things, before moving to this, question is very, very interesting, and I have exactly the same opinion and thoughts. So I'll tell you a very interesting thing that happened last year. So one of my friend who runs, who is a professor in mechanical engineering in IIT Bombay. Now he was researching on the Young's modulus and the other characteristics of materials. Now we realized that we needed to do like strength of the material. We need to predict based on the crystal structure. Okay, so it was a pure research project in mechanical engineering. Okay, so I talked to him and I also gave him ideas like we can do this way, that way, and we basically built a basic model. But then, and it worked. It was around 83% accurate as compared to human. In case of human simulations, the accuracy was below something like 60%. In our case, we were around 83 or we reached to 90. Now we needed to do more and more work. So we were hiring a couple of PhDs at IIT Bombay. And when we hired PhDs, we realized that they needed to go through the machine learning course. These PhDs were hired for mechanical engineering research. Okay, and we realize that unless the candidates learn about machine learning, they won't be able to perform even in PhD. So at that point of time, we gave we used to run another E&ICT course at that point of time, which is basically the foundation for this course. We gave that course to those PhD candidates, and they were able to do wonderful research, and they even have published the paper. So this is something that I have a concrete example to tell you that whether you are doing a research in mechanical engineering, material sciences, aerospace engineering, and anywhere, like for example, Perseverance, that Mars rover that was dropped, the prediction of its like opening of the parachute time was done using machine learning. And that's something, an example, whether no matter which branch of human sciences you are, this course is going to help you learn to predict hard things. And I can assure you this part. I have seen multiple examples. All right, so I hope I was able to answer the question. Wonderful. Now, there is another question. Question is, I don't have any programming knowledge and I have 7 years of experience in project management field, mainly of industrial construction. How this course will help in gaining knowledge about ML and AI? Okay, okay. All right, so I'm going to try to answer this question. And this question is something that would be asked by many people. And feel free, if anybody else wants to take up from the panel, all right, please feel free to, put in your thoughts at any point of time. And yeah, so question is that you have 7 years of experience in project management, mainly in industrial construction, right? So first of all, I would like to tell you that learning programming would help you a lot. That's why we have added a Python course, complementary in this course. And that Python course is going to make you really comfortable in processing data, doing all kinds of churning on data. And that will also help you when you learn a programming language. It helps you think better. Now, once you're done with that, then you'll move on to use the machine learning and AI. And I've seen that no matter where you are, the more cross discipline you are, let's say I just give an example of mechanical engineering. Similarly, your project, you will find that you can apply machine learning and AI in your project, because every human sciences is all about prediction, right? You are an astronomer, you would be predicting something. You are an agriculture scientist, you would be predicting something. Mathematics, the entire equations, like you see any formula, it's about predicting an answer. So you take any branch of human sciences, it's all about predicting something. And what does AI machine learning provides you? A set of tools to predict the answer based on the historical data. And therefore, this course is going to enable you to be able to solve your problems in your field, in your vertical, using the data. And that's what it is about. It is essentially learning to use a new kind of calculator. It's essentially learning to code a new kind of calculator, learning to program a new set of libraries, new set of mathematics, and that's about it. All right. So this is essentially right. My answer. If anyone from would like to add anything from the panel, I would like to. All right, so let's move on to the next question. Question is, do you teach building machine learning data models? Of course, this course is all about teaching how to build a machine learning model. Not only how to use an algorithm, but we start from the scratch, how to analyze data, clean data, how to build the pipeline, how to do entire thing. And that's our first focus. That's our primary focus, because if you look at the course curriculum, the first thing that you will learn in this course related to machine learning is how to build end-to-end project. That's a very counterintuitive, because usually you learn all the things and then there's a project. Here you do the project first and then you learn individual concept. Now the reason is that when you do the end-to-end project, you will get the gist of the entire process, so everything will fall into the place. Otherwise you will get bored and you will start questioning that why are we learning decision trees, why are we learning this neural network, if you're not able to put pieces together. So our focus is that we start with basically learning the data models, and that's how it is. You will learn to build the model, and if you can't, trust me, it's a shame on us. Almost everybody has to build one project at the end of the course, and in past everybody has been able to do. The people have published research, people have been able to figure out new problems. There was somebody who was a mechanical engineer at the ship, and what he did was he built a model to predict the remaining life of the equipment. That is from my class, and he has published the research. It got accepted as a very, very successful project in his company, and I'm very happy about this fact. So it is going to be this kind of real hands-on approach. Okay, wonderful. And anybody wants to add to that? Nobody? Okay, wonderful. All right. So that was what are the chances? Question is, what are the chances to get a job in industry after having 8 to 10 years of teaching experience, and any assistance for this? Of course, good question, good question. So question is that if somebody has 8 to 10 years of teaching experience, is there any chance of getting a job? Of course, of course. Now that's the beauty about the current time. Okay, instead of only asking about your past experience, people also ask lots of hard questions. So Venkat can answer this better, that at Google, they do not ask about your past experience and in any of the interviews, right? And
Indeed,
okay.
Sandeep.
And they basically look at your knowledge. They would give you a problem that here is a situation, a circumstance. Let's say, how would you build, how would you predict, how would you give the recommendation of places based on the current location of a person? And what are the parameters you will come up and all of that. So most of the companies, the way they hire is based on how much knowledge you have or how much understanding of subject you have, rather than where are you coming from. And most of the companies, great companies, they value diverse experience of the past. And that's something that I've seen in now, that Unlike the olden times when the people did not knew how to measure somebody's knowledge or skill, they would rely upon references, they will rely upon your CV, they'll rely upon your past experiences. But now, since people are able to measure whether you know the subject or not, they don't that much rely on your profile. So the knowledge is the most important thing as of today. A question is, which one is important for beginner in data science, machine learning or AI? Okay, okay. So I'm going to anyway talk about machine learning and AI very soon. So AI is the objective, while machine learning is a branch of computer science, right? Where you learn all the tools. So AI is objective and ML are the tools to reach that objective, okay? For a beginner in data science, you should basically take a look at the curriculum of this course that we're talking about. And that sequence of things is something that I would recommend anybody. Okay, just even if you are not enrolling in this course, I would suggest that follow that sequence of things. Follow that sequence of things. We have designed it, the way that you can't take away any of the piece from this entire course. And so I would strongly suggest that you take a look at the course curriculum, follow exactly the same curriculum. That will help you if you're a beginner. Is there a specific public cloud that we use in this course? Is there a choice if you want to focus on a specific cloud provider or implementing some of the data AI workflows? Okay, so basically, we do not have restrictions. Okay, we do have our cloud-based lab, right? But the agenda is not about selling CloudxLab. Okay, agenda is not constraining you. Agenda is about empowering you. We do not have a special product. Instead, we have the generalizable skill. The product that we have is something that is there in everybody's systems, like a Jupyter notebook, the Linux, the NumPy, SciPy. So all the tools that we are providing are something that is open out there, used by industry, right? But in case you want to use anything, feel free to do so. We welcome that. We welcome that. In one of the projects, somebody used Collab, somebody used something else, somebody came up with the idea that why want to build a project using Azure ML, and we welcome that. And that's how it is. Okay, so it is not about what we are trying to propagate. Our agenda is not about selling a particular software. Our agenda is empowering the learner so that when they go anywhere, they are successful in their career. And a question is it necessary to have full knowledge on linear algebra to delve into ML and AI? Anybody wants to take that? Gaurav and anybody? Praveen, Venkat?
Okay, linear algebra, mathematics underlying machine learning, little bit knowledge about linear algebra would be helpful in terms of better understanding the concept. However, the way we would be covering, we would be explaining you well. So obviously, all of us in our graduation and 10+2, we might have gone a little bit algebra, linear algebra concepts. So we'll cover it in such a way that you won't, feel the need to have a topic, a lecture on linear algebra itself. Whatever concept that we are explaining in the machine learning, we'll touch upon the requisite that come from linear algebra, and you won't need the field to have full-fledged linear algebra, lectures.
Okay, wonderful. Thank you, Gaurav. Thank you for that answer. In brief, I would like to add that basically we have provided basics of linear algebra as part of the course, but in the form of very hands-on way, how to solve a linear algebra problem using scikit-learn or NumPy. Okay, so do not, right? You won't be able to miss that. Now, question is, what's the difference between SQL and Spark? Okay. All right, I'll just give you a brief. Spark is a framework to get something done using multiple computers, right? You want to sort the data, you can ask Spark to use hundreds of machines to do the sorting for you. Sorting as in ordering the data, because ordering is a hard problem. While Spark is essentially kind of a tool running on multiple machines and doing the processing for you, right? It can run on top of existing yarn or other things, right? You will learn this thing in more details. Now, writing exactly that you should do this and do that on every machine is hard. That's why there is Spark. Now, Spark is very wonderful when it comes to processing. You can ask Spark to do something using any of the programming languages. You can use Java, you can use Scala, you can use Python, and you can use SQL. And that's a wonderful thing about Spark, that you can use so many tools on top of Spark. So when you are, let's say, running a SQL query to filter results, let's say you have 500 terabyte data stored on, say, 1,000 computers, you have stored 500 terabyte data, right? And you want to filter this data and order this data based on certain characteristic, right? In such circumstances, you will use Spark and you will talk to Spark using a language SQL. So I hope you get the picture. SQL is a structured query language with which you talk to any and most of these systems if your data is in tabular form. If your data is in tabular form, and it is stored on MySQL, Postgres, Oracle, any of these databases, then also you can talk to it using SQL. If it is stored in Spark, then also you can talk to it using SQL. So SQL is like a lingo, a language, and Spark is like a system where you can talk to the system using this language. Wonderful. If anybody from the panel wants to add, please feel free to do at any point of time. All right. Question is, I understand that IIT classes and assignments are very difficult. How I to pick up the concept and how I get support for any concept, whether any exam is conducted to finish the course. Yes. See, this course is difficult, but it doesn't mean that you won't be able to do it. It will be difficult, but gradual difficulty. So we are at any point of time, as Professor Gaurav and Professor Sanjeev Manhas already told, that we are going to make sure that you're not left behind. And in case you're left behind, you just let us know. We will organize complimentary classes. And we, as well as IIT Roorkee, as well as E&ICT, we're going to make sure that you are able to run with the course. Second, there's an exam. Yes. So the way we have designed the exam is on the lines of what industry expects you. Industry expects you not, industry does not expect you to be genius at coming up with an algorithm, new algorithm, no. Industry expects you that given a problem statement, can you come up with a model using existing algorithms? Okay, and this is exactly that's exactly what you will learn as part of this course. And if the model is not performing, how do you optimize it, fine tune it? In case it's not able to work, how will you make it work? Like if it's running too much, consuming too much memory or consuming too much CPU at the runtime, how would you optimize? So those kind of things we are going to take. And since we understand that it's a hard course, that's why we have gathered the experts from every domain, and we are going to execute this course on subject-wise basis. Like the experts who are, will be teaching your subject would be somebody who are really good at that particular topic. Is it necessary to have full knowledge on linear algebra to delve into ML and AI? Not really, not really. Whatever would be needed, we would be teaching you that. Don't worry about it. Okay. Easiest thing to say to people is, for learning machine learning, go and study linear algebra first. But how much? Right? So that quantity, adequate quantity of linear algebra, we will take care in the class. Don't worry about that. All right. A question is, does this course cover natural language processing and related DL approach? Yes, yes. So the way course is structured is that there is a chapter on recurrent neural network. Recurrent neural networks are basically a kind of neural networks, and recurrent neural networks are used a lot on the processing the natural language, but there are other newer models that we're going to talk about in this course, transformers and the bidirectional ones, bidirectional RNNs, and so on. So you will, I think probably Venkat will give you a bigger overview in his class. NLP one is it's his domain expertise, how to use the DL model, deep learning models in NLP. We will also be covering a classical, like how to use the classic approaches in NLP, like the bag of words, TF-IDF, and so on. So we will be talking and like parsing of the grammar, cleaning up of the sentences. We will also be learning in this part of the course in NLP. So there's a dedicated chapter on NLP that start with classical approaches, and then we go deep dive into the deep learning approaches. Okay, so that's there is a question, does the course cover, okay, so we have already talked about that. Can we learn the concept of the course after a gap of programming? As I have done programming in 2010 and I had gaps of few years, will it be a career restart? Okay, so just like you do not forget cycling or swimming, you do not forget programming. Okay, so even if you have done programming long back, you would be able to pick it up. And I can assure you that I have had similar candidates in past, and they have done wonderful in their career. All right. So usually when you have a career break, the way to resume your career is to pick a technology which is new to most of the people. And machine learning and data sciences is that there are people, but even person who has been in industry for 10 years, let's say somebody in IT for 10 years or embedded computing for 10 years, they also will have equally hard time like you learning new technology. So the new technologies such as machine learning, data sciences, big data, and so on, they are creators of the level playing field for everybody. Okay, so thanks to it, everybody has basically, this is what I'm seeing, that even people who are in career, they're taking career break because they're realizing that their skill is of no use elsewhere. The skill that they have gathered at certain company, if that company lay you off, the skill may not be enough generalizable, and therefore they're attending this course and they have taken up the course in past. So the idea is that you basically upskill yourself in generalizable and applicable applied knowledge. And generalizable knowledge and applied knowledge is not necessarily something that you will learn at a job, and that there would always be intervention needed. Therefore, don't worry about the career gap, and trust me, it's not going to keep you behind in, right? It's essentially a level. I mean, the newer technologies are the creators of level playing field equally for everybody. All right, so those were the questions. Anybody wants to add anything to the last question? Feel free to speak up. So thank you, everybody. Everybody, we will take a 10 minutes break. And after the break, what we are going to do is me and Venkat will be taking the introductory session on what is machine learning, what is AI, and the various career option in machine learning and AI, followed by remarkable examples by Venkat on the current use cases of machine learning in industry. So do stay till the end. My request to everybody is do stay till the end to get to know a lot about machine learning, AI, the use cases, and the career options in machine learning. All right, so we'll take a 10 minutes break. We will be back by 9 9:25 p.m. IST. Please convert it to your time zone. So we will be back by 9:25 p.m. IST. Let's take a break for 10 minutes and be back by 9:25 p.m. IST. All right, so great. Let's start and wonderful. So let's get started. So those were, Venkat, are you able to hear me? Perfect. So wonderful. So the format of the discussion, it's going to be a bit of discussion, and we are going to ensure that you all are with us. And what we are going to cover now is we are going to talk about what is AI, what is data science, what is machine learning, and a career in these. And then we are going to talk about the machine learning a bit. Okay, talk about the use cases. All right. So probably we'll spend more time on the use cases than the remaining part. All right. So I'm going to go, I'll jump directly into the machine learning part. So machine learning is essentially machine learning from the data, as simple as that. A machine learning from the data is a field of study that gives the computers the ability to learn without being explicitly programmed. All right. So essentially, this is the basic definition of machine learning. It's not machine language. We are talking about machine learning. Usually, we confuse the two things: machine language and machine learning. Machine language is something like a language, object format language, kind of assembly language, which the machine understands. Okay. All right. So we're going to understand this definition, because this definition, though it is single line definition, but there's a lot of, a big background to it. And let's understand it with real world example. So for example, do you think that Mario, the game Mario, can be learned by the way of automatic? Like, can a computer learn to play Mario? So here is the game where I'm sure that most of you must have learned Mario in your childhood, and you must have played Mario. Question is, can the computer learn by itself by playing over and over? By playing this game over and over, can the computer learn it? The answer is yes, and that's what we are going to talk about. So in this demo, in this video, the computer learns to play Mario. It basically observes the game and the pressed keys, and also observes the score and tries to maximize the score. Let's take a look. So here we go. So this is the day 0. You can see the program is pressing the keys and just observing the screen, and it's going nowhere. It dies of old age. And after a couple of more tries, it becomes a bit better. You can see that it's able to move, and it's not that smart, but it's able to do things. Now, so this is a classic example of reinforcement learning, where the model is learning by the way of interacting with the environment. Now, after a couple of more of gameplays, it's able to, not couple of weeks of gameplays, it's able to do good job. You can see that. This is actually like me. This is how I would play if Mario. I'm not that good at it. You think he'll cross it? You can see that. Can you imagine that this computer has learned it by itself? Nobody taught it. Nobody taught it gravity. Nobody taught it what is Goomba. Nobody taught it anything other than the objective. Few more weeks of playing the Mario game, the computer is now awesome. Now you can see that he's able to do something like a magic. What was that? You can see that. What was that? The Goomba is falling on it and it starts moving downwards. So it found a bug in the collision detection of Mario game. And that's the amazing part about machine learning. things we never knew, it figured it out. Now you're going to see something more amazing. This, I have no clue. How did he do that? He just jumped it like that. Now you're going to see another sign of intelligence here. When it's not able to succeed, it just pauses the game. It just pauses the game, just like our childhood, when our siblings were not able to succeed against us, they will spoil the game and basically go and run away. So in the similar way, the computer was pausing the game so that it doesn't lose. And that was the only strategy left, because anything it does, it was about to lose. So it kept on pausing the game. So it is more like generalized intelligence. So what we just saw was machine learning in truest form. The computer learned to play Mario by the way of looking at the data over and over and playing it, generating data. Now, the another thing that we have is the AI. The term was coined, the term artificial intelligence was coined by John McCarthy in 1956, along with his colleagues. There was this conference in New Hampshire in a college called Dartmouth, and there, Dartmouth, not Mouth, Dartmouth, and to basically they gathered there and just to define what exactly is AI. So the way it was defined is by the way of sub-objectives, because defining intelligence is very hard. Defining intelligence is very hard. So the way they define AI is by the way of sub-objectives. The first sub-objective is to be able to represent knowledge, like how do we express that the man is a father of a kid, something like that. So how would you represent this knowledge? That's the first sub-objective of AI. Like if a system is able to do it, so it has met one of the sub-objectives. Second is perception. Can a computer or the machine is able to perceive, see things, not only through the eyes, through the visual means, but also by the way of other sensors. Say, for example, Kinect, the Xbox Kinect senses through, not only through the visual, the cameras, it senses through the infrared and so on. So that's perception, being able to perceive or see. Third subcomponent or sub-objectives of AI is reasoning. Reasoning in the sense that can a computer, can a machine can a machine prove a theorem? Can a machine do the logical reasoning of playing a game like chess? Next one is navigate. Can the machine navigate or move from one location to another without bumping into things and choosing the fastest possible route? And the fifth sub-objective is the natural language processing. So these were the 5 sub-objectives of AI. So if a machine is able to achieve these sub-objectives, we will call that machine to be intelligent or artificially intelligent. Now further, how do you achieve AI? So that was sub-objectives. AI is about an objective, saying how would you build a system which can demonstrate AI. For that, you basically need all kinds of things. On one hand, you need software. On the other hand, you need hardware. So you would be surprised to know that like, for example, take an Alexa from Amazon. So Alexa is an example of an intelligent machine, the AI machine. Now, the Alexa, a large part of Alexa is actually human coded. So there is a hardware, there is a software. In software, there are 2 kinds of code. One is written by the people and other inferred by the machine based on the data. And And inside the machine learning, there's a subdomain called deep learning. Deep learning is essentially designing your logic in a neural network way. So this is essentially software and hardware. So this exactly is AI. I'm going to do a very brief walkthrough about the career. Feel free, Abhinav and Venkat, do you want to add something? Anybody else? Yeah. At this point of time? Yeah. Nothing else? Okay. Moving ahead. So the next thing I want to tell you is that where are these dots connecting? You hear machine learning, you hear data science, you hear Android programming, you hear analytics, and so on. Where do these dots connect? Okay. Where do these dots connect? Are they overlapping fields? How exactly? Where exactly are these things needed in the real world? Okay. So a lot of life starts with gathering data, right? Whether you have sensors, whether you have a website, all of these are a means to gather data, right? So when you're gathering data, you gather this data at a place which is cheap, less costly, whether it's Google Cloud, Amazon Cloud, or you build your own system based on HDFS or Kafka or HBase and so on, right? So this is the starting point in the life, in this cycle. The second part is about cleaning it. When you have petabytes of data or terabytes of data, or you have small size of data but coming at a very fast rate, how do you clean it? The cleaning is usually done using all kinds of tools. Some of them are normal, SQL based. Some of them are normal programming based. Some of them are, if the data is bigger, then you use things like Spark RDDs or Spark SQL or Spark MapReduce or normal Hadoop MapReduce, or you sometimes use Informatica kind of tool to do the ETL. ETL stands for extract, transform, and load. That's a branch of information technology. There are many tools out there. The third one is once you have cleaned up this data, you need to do basic analysis. And to do the basic analysis, either you will use the standard tool. If the data is small, you might use NumPy. When you have like simpler tools, like simpler data, like smaller data, you might use the tools like NumPy and other tools to do the basic analysis, or SQL. If your data is in database, you can use those tools. But when you have bigger data, you might need Hive, Spark SQL to do the analysis of the data. And once you're done with that, then once you have cleaned up your data, then you will start applying the machine learning algorithms to do the prediction. And for that, if the data is small, then you will use R, you will use normal scikit-learn. If the data is bigger, then you will use tools like MLlib. If your data is in the graph form, you might use the tool like GraphX and so on. So that's first, after you have built the basic model, it's time to optimize the ML algorithm, let's say overfitting, underfitting, and other things, and so on. There's a lot and lots of engineering that goes here. Optimizing the models, not only ML algorithm, but optimizing models. So for that, you will need all sorts of tools, not only TensorFlow or understanding of other algorithms, deep dive, and so on. This is where a lot of knowledge is needed on the subject. Lot of knowledge. Till here, you can just use the out-of-box available tutorials. But when it comes to here, the machine learning engineer's role truly comes out, because here you need the knowledge of all the things that you have studied so far. Okay, so this is the place. And once you have done till this point, now once you have this rock solid model which is performing great on your test data, then you will move it to production. Production is in deploying on the server. All right, so for that you need to know how to build a software like a website or REST service. You should know how to build Android apps. You also need to know the DevOps. And this is also, there are a couple of lectures as part of this course where we will be covering DevOps, though it was not planned when we started it. But now when I discussed with the team, we discussed with Venkat, we discussed with other faculty members, we agreed upon that we will be doing the ML Ops one couple of lectures as part of this course. All right. So this is the entire flow of machine learning. And the other thing is about the job. The data scientist job has been called one of the sexiest job of 21st century. There's a reason to it. If you look at the jobs at the top companies, top software companies, or top paymasters across the world, unofficially, every software engineering job for experienced people involves machine learning questions. All right. It involves machine learning. People expect a senior engineer to know machine learning, to know engineering, data engineering. All right. And this is going to grow. And this is very clear further and further. Thanks to COVID, we saw that the software is eating the world, right? And software, what software did to rest of the industry, machine learning is doing that to software. Most of the jobs which were about using a specialized software or your skill in that particular software were great, but now that skill is just one part of the skill. Every software engineer, whether you are Salesforce engineer, you are ETL engineer, you are informatica engineer, you are web developer, and so on, everybody is expected to know machine learning. Everybody is expected to know machine learning because that is a common knowledge that impacts the entire application. And without the knowledge, you won't be able to actually contribute to the machine learning flow, the one that we just discussed. And across the globe today, you can see that the machine learning jobs are growing and AI will dominate. Most of machine learning jobs are going to dominate. Now, I hand over the discussion to Venkat. Venkat would like to go through a couple very good, very interesting examples that myself am looking to here. Over to you, Venkat. Please go ahead.
Thank you, Sandeep. I'm just going to share my window with the presentation. So, okay. So, can everyone see the screen, full presentation mode? I assume it's okay. Is it okay? All right.
Yeah, it's all fine.
Yeah, this is good.
Excellent. So let's start. I mean, I want to start before talking about these projects to continue about what Sandeep essentially said about why is artificial intelligence getting more and more important. Now let's consider this whole notion of ghost kitchens, right? Which the founder of Uber, ex-founder Travis Kalanick, has started. Now, what is a ghost kitchen? I mean, your typical mom and pop restaurant business has 8 to 9 employees, right? Apart from the chefs, you've got the servers, you've got the restaurant manager, you've got the cleaning crew. But with the notion of a ghost kitchen, you've reduced your staff essentially to 2 people cooking, and you've centralized with artificial intelligence everything else: cleaning, delivery, management. You have a giant warehouse where you've got many micro units of these mini kitchens with 2 employees each running the show. Now this is scale, right? Where we've taken a conventional industry and completely radicalized it. Travis Kalanick did this with the taxi industry, right, with Uber, and now we're seeing that with this whole ghost kitchens model. So I think I'm going to start, just continue that and go through some real world examples. And the first example that I would like to talk about, I'm very proud of this because this is the first time that the CEO of Google actually presented something that I was a tech lead for. If you look at this is done at the Google I/O, where Sundar presented something known as Duplex AI, the assistant for the web. The essential goal is to predict the next user action to make an online reservation or a purchase through artificial intelligence. Now, I spoke about it briefly before, but why do you think this is fundamentally difficult? Now, the internet is a blob, a giant blob of thousands and thousands of sites, right? There's no conformance that all Hertz or rent-a-car sites stick to this template. There's no conformance that Mintra's shopping HTML is the same as Gap or Banana Republic or Levi's Jeans or anything else that is there on the world. So if you want to automate the web, how do you actually learn the web? And so the technique that we used leverages something, I mean, Sandeep alluded to this. It's called reinforcement learning, but we used a specific branch of reinforcement learning called imitation learning, where we had experts, human experts, learning how to buy movie tickets, right? We had a few hundred of these experts. This is called few shot, right? We start with this. Then the machine learns on and on. It makes mistakes. Oops, I need to go back. I need to backtrack. So through imitation learning, we have essentially learned how to book through Hertz or any of the other portals. I mean, of course, this isn't perfect. I mean, and there might be some bogus websites where we fail to detect where the buy button is. So instead of buy, we might log in instead. I mean, that hasn't really happened. I'm just giving a scenario where one needs to be really careful. But this again was another scenario where conventional tools or techniques wouldn't work, right? Because there was nothing available to do this out of the box. So you had to take, yes?
I have a question.
Yes.
Is it the imitation learning and the behavioral cloning are the two same things?
I mean, I would say behavioral cloning is a very, very specific type of imitation learning, because there is also adversarial techniques in imitation learning where you false imitate so as to game the system, right? So behavioral cloning, you exactly want to clone the behavior of the expert tracer, but sometimes you don't want to do that. You want to negate that so that you learn the reward more. So that is a facet too. Great question, Sandeep. So I think I will go to the next question. I mean, if you haven't used Uber Eats, you've probably used Swiggy or Zomato, or in Brazil, it's called iFood, a giant meal delivery application, right? Now, the fundamental problem, again, Sandeep's used the word predict, and I'm going to keep that nomenclature, is to predict the total duration of this complex multi-stage process and to recalculate at every step. Now, let me go into each of these stages in detail, right? So you as a customer, you place an order that gets sent to the restaurant. The restaurant acknowledges and prepares the order. Now, the time is gated on how busy the restaurant is, how popular the restaurant is, and how complex your order is. You might, and I know in India, Swiggy heavily markets that you can order a single dessert. Compare that versus a 10-course meal. And again, the delivery partner, right? This is the fundamental aspect. Let's talk about the traveling salesman problem or the door-to-door salesman, right? As in, how do you optimize the delivery time? The delivery partner has to find the right parking spot, go to the restaurant, collect the order, go back, find the location, deal with traffic, the fastest route with traffic chokes, and all in a certain period of time where the marketing strategies like 30 minutes or we pay your full order has to work, right? So that's essentially the onus on your machine learning algorithm. You have to make the business objective of 30 minutes or less for this really complex multi-stage process to work. So how do Uber data scientists actually do this, right? And I think some of the key things, let's take a look at feature engineering. I mean, Sandeep spoke about this, right? So what could we take for the features, right? The time of day. Yes, Sandeep?
I have a question before we
Yes,
proceed.
please.
This might be a little, a crazy question. Question is that the recent incident of Zomato, can we blame it on the machine learning? If you do not
Oh,
know the recent
I
incident,
mean,
like
I do know the incident, but I don't know if it was a problem of the system or if it is a problem of the human beings involved in the scenario, right? So I'm not qualified to answer that, but
I think we have.
I think you brought up a very valid point of if a system goes wrong, this actually has caused significant distress to a 5-star employee, right?
Well,
Whose life and
yeah.
exactly. So I think that aspect is important.
Okay.
But thank you, Sandeep. I mean, going back to the problem, I mean, okay, the time of the day, the delivery location, right? That's you're going to take from the current request, right? You're going to take historical features, average time taken to prepare the meal for the last 7 days. Now you need near real-time features, average meal preparation time for the last 1 hour. Now this is just a few features that I'm talking about this. Now you need to deploy this across thousands and thousands of machines in near real time for the entire customer base of Uber. And think about the scale of the problem, right? Now, not only does your machine learning model need to make accurate predictions to avoid catastrophic scenarios like employees losing your job, you also have your model to be fast enough to, at every step of this stage, maybe in milliseconds, right, to actually ensure that you can do this. And since you're talking about models, I will just mention briefly that Uber leverages something known as boosted decision trees, right? A decision tree is a data structure where at every branch you take a decision in a certain sense. So, oh yes, based on this time of day and this delivery location, I might branch it this way or that way. So that's just one facet. But Uber has an entire platform called Michelangelo, which facilitates someone deploying a model to production in a matter of minutes. So think about that. That's a question of scale. Let me now move on to, one second, Netflix, everyone's favorite pandemic application. Unless I hear otherwise.
Yes.
Now, I mean, this is a very, very hard problem, right? I mean, improving, let's consider video streaming quality. Let's take a step back, right? Obviously, a one size fits all for streaming videos does not work. And why doesn't it work? Okay, I mean, you might view Netflix through your mobile devices, right? One might be a Huawei P30 Pro. something might be like, I don't know, like the oldest generation Snapdragon Core version. You might be watching it on your Samsung Web OS smart TV, right? Cellular networks may be more volatile and unstable than fixed broadband networks. Networks in different geographical locations and markets experience different levels of congestion. And different service categories of networks have different capabilities and fidelities, right? Due to hardware differences. I mean, we know about fiber optic and broadband as one example. So I think the key aspect is, can we predict the quality of the network to adapt video quality? Now, this is an important thing. So when we think about networks, okay, I mean, if we refresh our computer science brains, I mean, there are two things, okay, average bandwidth and round trip time, RTT, right? I mean, everyone's got these concepts sort of baked in, but these static indicators are definitely not true indicators of a time shifting pattern as you see on the top, right? I mean, your network stability and predictability, entropy of this system is so large that you need a richer characterization of a network than average bandwidth and round trip time. And so Netflix has taken this problem in a certain sense, modeling it as, can we predict what the network quality or the throughput of the network will look like in the next 15 minutes, given the last 15 minutes of data? So this is how they fundamentally distill the problem, right? And I think I'm gonna talk about, like, how are they actually doing this, right? Again, let's go back to reinforcement learning and a specific type of reinforcement learning approach called temporal credit assignment problem. So, like, using the notion of, you divide your network into 3: high quality, medium quality, and low quality. You divide that into slots, right? And at each slot, your reward decision is, okay, should we play, should we buffer, or should we download? And I think that the trade-offs in this space, okay, if you download a lot, a priori the streaming experience is going to be smoother. But if you don't do that, so it's a constant time-shifting reward space where the credit assignment problem and reinforcement learning algorithm leveraged by network has been really effective. I'm not sure how many of you complain about Netflix streaming quality, but I don't.
So those who are not aware, so we are going to talk about temporal credit assignment problem as part of the course.
Excellent.
And this is a wonderful example. Thank you. This is a big, something that I learned new today. Go ahead.
All right. And, oh, sorry. Okay, the last thing is super interesting. Music generation with neural networks. Now, you might be thinking, what's the big deal about automatic music generation? I mean, if you're in India, Anu Malik has been doing it since the 90s, right? So, but let's actually, even a prominent music auto generation approach has been to approach it symbolically, taking like piano rolls, adjusting timing, pitch, velocity, and the instrument of each note to be played, right? I mean, but this symbolic approach has limitations, right? Human speech is not symbolic. It's subtle. It's got timbre, tone, like expressivity, like the fact that, why does a song make you cry? If it was purely an automated voice that, like, Google Maps or your Uber thing gave you, I'm sure you wouldn't feel the same emotional connect with that, right? So I think the key thing is they wanted to model this, right? So rather than taking it as a symbolic approach, they wanted to use it as model music as raw audio. Now, why is this a challenge? Now, generating music at the audio level is challenging because of very long sequences. Now, let me talk. What do you mean by very long sequences? A 4-minute song at CD quality, which is 16-bit 44 kilohertz, has 10 million time steps.
Yeah.
Now, GPT-2 from OpenAI, like this giant language model that you spoke about, has 1,000 time steps. OpenAI 5 has tens of time steps. This is 10 million time steps for a 4-minute song.
Yeah.
So to learn the semantics of music, a model has to deal with extremely long-range dependencies, right? And this is where state-of-the-art compression comes in, right? Where you need to compress raw audio in an extremely higher dimensional space or lower dimensional space by discarding perceptually irrelevant information. I'm not going to call it noise because it's not background, but it's perceptually irrelevant. Note the nuance between noise and perceptually irrelevant. Now we need to train it in this space and then decode it back to the raw audio space, right? I think I'm not gonna I think the paper is very complex. It's gonna go into it, but I'm gonna just 1 second. There's a sample explorer for jukebox.openai.com where you can just mix and match various genres and try it.
Nice. We'll try
But
sometime. Yes.
But let me talk about one thing, and this is all right. They have learned this is something called stochastic neighborhood embedding, right? Of what? Of essentially music composers, right? They've essentially this model in I don't know how many dimensions of space. We've reduced it to something which our brain can understand in 2 or 3 dimensions. And with this concept of stochastic neighborhood embedding, we can see that, oh, wait, the classical composers are clustered together. The pop composers, though I wouldn't call Frank Sinatra a pop singer necessarily, but you see that the artists are sort of clustered together. And how did the neural network really learn this? Right? How did it learn to do this clustering? And so I think, again, when one works with algorithms at very, very high dimensions, this shows that your debugging is always in 2D. Right? So I think this is one facet that we talk about.
Right.
Cool.
Wonderful. So essentially, the way connoisseurs of the music, the people who have understanding of music, they can classify various singers into genres. Similarly, my model essentially learned those characteristics of the music so that it could group them together, right? So that's a wonderful, thing that has been done. All right. So any questions at this point of time? All right, seems like most of the questions are answered by the team. And all right, so wonderful to have all of you in this session. I hope this session was useful, right? There's a question, how can we use DS, ML, AI, and payment domain? I'm going to share my screen instead of sharing the screen. Okay. All right, so this was something that we discussed, or we can just turn off sharing right now because it's not really needed. All right, so wonderful, wonderful, and feel free everybody to take up the question or just raise the hand and I can. Okay, so there are a couple of questions that we would like to answer. We know that we are going beyond time, but let's not let's just stay for a couple of minutes, maybe 10 minutes more. And question is, how can we use data science, machine learning, AI in payment domain? I'm working in payment and banking domain. All right, all right. So I mean, just like database was invented, I mean, the first users of database were payment systems, right? Like banking industry or accounting industry were the first users of database. Similarly, the banking domain is also one of the initial users of machine learning. Okay, there have been lots and lots of lots and lots of wonderful use cases in payment domain, whether it's fraud detection. That's one thing that I did at DE Shaw long back. The anti-money laundering and fraud detection, and in payment domain there are many more complex problems, like giving a credit score or the history of an individual. Is he eligible for loans? Is this particular behavior a fraudulent? So there are so many use cases in banking industry. It's a matter of, I mean, last year I was teaching Standard Bank, and almost every of their engineers were attending from across the globe, and I found that there are so many use cases in the banking industry. Almost every branch of the, whether it's loans, whether it's fraud detection, whether it's anti-money laundering, reconciliation, and so on. So there are so many amazing use cases over there. And question is, so the further question is, how can we use data science machine learning in card fraud and risk management? So the credit card fraud, like think about credit card transactions, right? So you have a certain behavior, like how many transactions have been done in last 10 minutes? What were the amounts of those transactions? Did they come from nearby locations? Did they come from faraway locations? Did they happen from a particular country or another country? So given all these features and characteristics of a transaction, machine can learn and figure out what is it that right, which credit card transaction could be a fraud or real. And based on that, you can mark whether a transaction has a risk or not a risk. We use a transaction service called Stripe, and they very often mark a particular transaction as fraud based on the historical or the current real-time behavior of that particular credit card user. And that's fairly accurate. Now, there's another question. There are a couple of questions, so let's take it. And if you want to take up a question, just anybody wants to answer the question, please let me know. I would, right, please, I'll not answer the question. Okay. Question is, I am a PhD student, but willing to take career with data science and machine learning, but limited programming. Will this course help? Okay, let me be very honest to you. This course requires programming skills. But if you do not have that programming skill, there is a full-fledged course on Python, which is complementary in this course. And we would be giving you guidance on the Python course. So it would be, if you want to really go deep dive into machine learning and you want to be utilizing machine learning in diverse use cases, there is no, I mean, it'll be very difficult without the knowledge of programming. Okay, knowledge of programming, because I mean, it's something, you don't need to be, the James Bond at knowing all the function in every library. No, you only need to be having that aptitude that here we are going to use a for loop. This is we are going to do the if else conditions, and this is where we are going to do the multiple other options. So you should be able to visualize that part. And all right, let me. So I would say that, I mean, we have tried a couple of courses without the programming, But we realized that people with programming knowledge are performing better in the industry as compared to people without the programming knowledge. All right. Now, another question is there a cloud angle to the course? Any particular cloud of choice? And so, quick thing is that we don't have a particular cloud of choice. Right now, we are the CloudxLab is our own platform where we are hosting the Jupyter servers for our learners so that they can, do it in real time with the class. And we are not associated or affiliated with any cloud provider. Therefore, we are fairly agnostic with respect to technology. We would learn the technology which are general. Instead of a particular framework or thing, it is going to be general and yet applied. And that's the thing that we worked hard. We are not going to be, let's say, specific to Azure ML or Amazon ML. No, we are going to be something that which is applicable everywhere, most likely open source and available to everybody. Because the beauty of about the world is that I mean, no matter where you go, be it Google, Amazon, Facebook, everywhere is the same open source tools. And also, most of the tools the companies are releasing are open source. Like, for example, Facebook is releasing PyTorch, it's open source. TensorFlow is being released by Google, it's open source. And right, so most of the theory and everything is going to be platform agnostic. We are going to be using Python, NumPy, SciPy, scikit-learn, TensorFlow 2 basically, and those are the tools that we are going to utilize in this course. But from time to time, if needed, we would basically give you an overview of alternate systems, and we were going to also learn about the big data systems along with Spark. All right, so we are not affiliated to anybody. Our only interest is our users, our learners. Whatever is good for them, whatever makes our users successful, that's what we're going to do. All right. And right, a question is right, how do we use ML and DL in telecom? There are many use cases in telecom. Many use cases in telecom. Number one, detecting why users are leaving you, detecting the load, predicting load in a particular region at a particular time, and detecting the reasons behind right, predicting whether a particular equipment will shut down, and so on. So there are like lots and lots of use cases in the telecom industry. One of the use case that I came across was very interesting, and recently somebody approached us. The thing that they were trying to solve is that can we establish a correlation between the settings of the equipment historically and the quality of the calls. So there's these towers where there are lots of equipment. They keep on changing the settings. They retain all kind of historical data about these settings, and they keep on tweaking these settings and observe. Like, we had to establish that by tweaking a certain settings, whether the call went up or down. Therefore, establishing a correlation. So the truth is that telecom industry is one of the the big data as well as machine learning, a playground. Most of these companies started the revolution when it came to the data. Is it related to numerical optimization? Numerical optimization is one of the optimizations. There are many more ways of optimizations. And the problem that we are going to solve is mostly a greedy way of solving the problem using the gradient descent and so on. Most of the machine learning we are going to cover is other than SVM, which is an optimization, right? Which is basically from kind of linear programming problem. Other than that, we're going to talk about SVM, and remaining part, though we're going to talk about the way to solve it using the normal equation, but most of the algorithm, whether it's neural network or the normal optimization, is going to be gradient descent, a greedy way. And how do we use AI and ML in education sector? Good question, good question. As I just said, we are using it to a very large extent. Okay, there are so many use cases you will be surprised to know. Like, for example, if you are in a lower education, like for a junior school, you can observe the happiness of the kids. Observe whether kids are happy, paying attention, or they are getting sleepy in the class. And that's very much possible today because everybody is online and we have the clear recordings of every learner. So starting there, there are so many use cases you will be surprised. One of the things that we recently built is that you can take a photo of the exercise book, and you can, and that tool will convert that exercise book into a Google form kind of assignment. And that's something really, really useful because we realized that most of the teachers were not able to use this online system to type in all the exercises because they are like just too packed. At the same time, they were not able to check their physical copies, and therefore the kids were not able to learn. And therefore we designed this tool. So there are so many use cases in education sector. Look at it closely. Look at your problem statement closely, and you'll find hundreds of use cases. In our case, we recently are working on something like predicting how many people will like a particular chapter, particular page, based on the historical evidence. And that's something that we're building. And given a content, we are predicting whether user will go for purchasing our lab, whether user will go for, they will exit our page, or will they sign up with us? Will they, navigate to our blog? What will they do given a page? So there are so many use cases in education sector that you'll be surprised to know. Okay. Question is, will we be taught how to build image recognition ML software? Of course. Of course. And right, just take a look at, come to CloudxLab, go to resources, go to project, go through the ML models there, and you'll be surprised that most of the projects are there already. And your presentation are already familiar with the programming language that will be required, but right. So whatever software is needed, we will be providing at CloudxLab, or we will, guide you how to install those softwares. That was the second question. So don't worry about installation. All you need to do is install Zoom so that you can attend this class. Remaining part of installation, you don't have to worry because everything is there on the cloud. We have made sure everything is available. All right. Question is, do you use AWS ML service in your course? No, we don't want to do that. But after attending this course, whether it's AWS ML, Azure ML, or some other party, you will be able to use them in a jiffy. Okay, because the generalizable knowledge is what we're going to focus. Open source knowledge is what we're going to focus, and that is what is applicable everywhere. A question is, I need a session on cracking interview in high profile company. Is it possible to have a session during the course? Yes, we are planning that part. All right, we are planning that part. Basically what we are planning is we are going to go through a couple of scenario-based exercise whereby given situation, you have to do like modeling of machine learning problem as well as the backend design problem. So those things will be, we are introducing as part of this course. And question is, kindly let me know whether there is any career assistance after completion. Of course, there is a career assistance. If you go to CloudxLab/resources, CloudxLab, go to CloudxLab, click on the menu resources, go to the job as Abhinav demonstrated in the beginning. So you will find lots of jobs listed out there. Please apply there. All right. So we are going to make sure that you get equal opportunity to apply in various companies. And ours is a continuous career assistance. It's not, that you attended just now our session and you paid us. Now only we will take care of it. No, we continuously, as and when people are posting jobs on our platform, we keep on sending updates to our learners and they can apply. And the relationship is lifelong with us. So that's about it. So thank you so much. I hope I was able to answer your questions. Wonderful. Thank you so much. Thank you, Venkat. Thank you, Abhinav. Thank you, Praveen. Thank you, Professor Manhas. Thank you to E&ICT Academy, and thanks to Professor Dikshit and Praveen. So wonderful to have a great, team and to deliver this course. And I'm sure that the people will be really benefited with this course with a wonderful faculty. All right. So anybody has to say anything other than thank you, everybody. All right. So that's pretty much.
Thank you all.